Intermediate algebra for statistics, using the quadratic formula to solve quadratic equations. Lesson objective: solve quadratic equations by using the quadratic formula. Lesson objective: the quadratic formula. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times ac, all divided by 2a. So the values of a, b, and c are the coefficients for the quadratic equation in standard form. A common mistake is to leave off the negative b when we are dividing by 2a. The 2a is dividing the negative b plus or minus the square root of b squared minus 4ac. Let's do an example. Example 1. Solve x squared minus 6x plus 8 equals 0. Solution. In this case, a is equal to 1, b is equal to negative 6, and c is equal to 8. Here we have the quadratic formula. Now all we have to do is substitute these values in this formula. So b, negative 6 goes here, and here. 1 goes here, 8 goes here, and 1 goes here. Now we follow the order of operations. We have to compute this first. Therefore, we have to compute negative 6 squared first. Negative 6 squared is 36, minus 4 times 1, which is 4, times 8, which is 32. A negative 6 becomes a positive 6, and 2 times 1 is 2. Next, we want to subtract, and we get 6 plus or minus the square root of 4, all divided by 2. Square root of 4 is 2, so we have 6 plus or minus 2 divided by 2. So this is two solutions: 6 minus 2 divided by 2, and 6 plus 2 divided by 2. 6 minus 2 is 4, divided by 2 is 2, and 6 plus 2 is 8, divided by 2 is 4. So the solution to this quadratic equation is x equals 2 and x equals 4. To check it, we start with the original equation. For x equals 2, everywhere we see an x we substitute 2. The left hand side should equal 0 because the right hand side is 0. So we now have 2 squared minus 6 times 2 plus 8. If 2 is a solution, this expression here will equal 0. We have to square first. 2 squared is 4. 6 times 2 is 12, plus 8. Next we subtract. We get negative 8 plus 8, and that equals 0. It checks. For x equals 4, the process is essentially the same. We substitute 4 in for x. That gives us 16 minus 24 plus 8. 16 minus 24 is negative 8. Negative 8 plus 8 is 0. It checks. So we have verified the solution algebraically. To verify using the graphing calculator, we type in the quadratic equation in y1. We press graph. It appears that we have an x-intercept at 2 and one at 4. To check it with the table, we hit second graph. We can see when x is 2, y is 0. When x is 4, y is 0. So we have verified using the graphing calculator. There is an additional way we can verify. That's using the value feature. If you press second and trace, which is calculate, number 1 is value, press enter. You'll see this screen is wanting to know what value of x do you want. Type in a 2, hit enter, and the calculator gives the output for the y, which in this case is 0. And when we do 4, we get the same value, 0. Let's do another example. Example 2. Solve 2x squared equals 10x minus 3. Solution? Our first step is to take this quadratic equation and put it in standard form. ax squared plus bx plus c equals 0. So this is not equal to 0. This is not in standard form. So our first step is to subtract 10x to both sides of the equal sign. And finally, add 3 to both sides, and we now have 2x squared minus 10x plus 3 equals 0. So the value of a is 2, the value of b is negative 10, and the value of c is 3. Substituting these values in our formula, negative 10 will go in for b, here and here, a is 2, 3 is c, and the denominator is 2 times a, which will be 2 times 2. Again, working inside the square root, negative 10 squared is 100. This will always be a positive number. Make sure you include parentheses. Negative 10 times negative 10 is a positive 100. 4 times 2 is 8 times 3 is 24. A negative negative 10 becomes a positive 10, and 2 times 2 is 4. Next, 100 minus 24 is 76. So we have 10 plus or minus the square root of 76 divided by 4. 76 is not a perfect square, but it does have a perfect square as a factor. So we want to simplify this. 4 times 19 gives me 76. So with the square root property, we can break this up into the square root of 4 times the square root of 19. And that gives us the square root of 76. Square root of 4 is 2. So we now have 10 plus or minus 2 times the square root of 19 divided by 4. Our last step is to look at 10 and 2 radical 19 and say, is there any factors that are shared with 4? And the answer is yes, 2. So we can factor out a 2 from the 10, and we can factor out a 2 from the 2 radical 19. 4 is 2 times 2, so this 2 and this 2 will cancel, and we are left with 5 plus or minus the square root of 19 divided by 2. That is our exact answer. Now there will be times we will want an approximate answer. To do this, we approximate square root of 19 using a calculator, and that turns out to be 4.36 to 2 decimal places. So this now becomes 5 minus 4.36 all divided by 2. The last step we divide by 2. And that gives us 0.64 divided by 2, which is 0.32. For the other solution, this is now 5 plus 4.36 divided by 2, which is 9.36 divided by 2, which is 4.68. So the approximate solutions for this quadratic equation is 0.32 and 4.68. To check it, we take the quadratic equation. Everywhere we see an x, we substitute 0.32. Now this should be approximately equal to 0 because we are rounding this value off. Square first, then multiply by 2. Now we multiply, subtract, and then add. And we get 0.0048, which is very close to 0. It checks. For the other solution, we take 2 times 4.68 squared minus 10 times 4.68 plus 3. This should be approximately equal to 0. Square first, then multiply, then subtract, and then finally add, and we get the same value, 0.0048, which is approximately equal to 0. It checks. To use a graphing calculator to verify, again we put the equation in y1. We hit graph. It's hard to see where the x-intercepts are. They are not integers. And if we use our table feature, here we see a positive number. For y, it jumps to a negative. stays negative, and then it goes from a negative to a positive. So we have some kind of idea that the intercept is in between 0 and 1 and in between 4 and 5. If we hit second and window, which is table set, change the independent from auto to ask, and go back to our table, when we type in 0.32, it will give us the corresponding Y value. And this is what we got when we substituted 0.32 in on the previous slide. If we do 4.68 and hit enter, we get the same value that we got in the previous slide. If we need to be super precise, we can actually type in 5 plus the square root of 19, all divided by 2. Don't forget your parentheses here. Hit enter, and it says it's 0. For the other solution, 5 minus the square root of 19, don't forget your parentheses, all divided by 2. Hit enter, and again we get 0. So we have verified the solutions for this quadratic equation. Thanks for watching.